All right, everyone, welcome to the Cerebras Podcast. Today, we have a special guest, a friend of the firm, Nathan Benaich, founder of Air Street Capital and one of the co-authors, the highly read State of AI report that comes out every year. Nathan, welcome to the podcast.
Good to be here, James. Thanks.
You are typically based in the UK and you're spending some time in New York right now?
Yeah, exactly. Summertime / springtime in New York's a good place to be.
Awesome. Air Street Capital is kind of like a boutique firm, I guess. Could you tell us a little bit about it? What is the style of investing? Do you just focus on Europe or do you do all countries? And if so, how does that work out of Europe?
Yeah, so it's a solo GP, so it's run by me. And I set it up because I firmly believe in thematic investing, that particularly for kind of new areas of technology which are fast moving, quite esoteric, quite technical. It really benefits from the investing side to be close to the metal, as it were. And I really enjoy being at that position. I was in grad school doing bioinformatics and cancer research, so I had some exposure to machine learning there, and love to like thrive in this community of scientists and entrepreneurs, and like kind of be this interface between people inventing things and commercializing things. So the approach is to build like a venture firm that's native to the community that it's born from and serves. I consider my work, or try to consider my work, as like core contributions to this ecosystem in the same way that other entrepreneurs are committing code or whatnot. And then the style of investing is, I guess, like quote unquote high conviction. It's between like 0 companies and 5 companies a year. Just 20 or 25 companies per fund. Taking it pretty slow, but want to make sure that every team and company I get involved in is sort of like dire in the sword quality of like, I think this is going to be epic. I think we can take a really big swing on it. It's typically a bit anti-hype, I would say. So trying to find like really important, compelling why nows that hopefully other people haven't figured out yet. And writing anything from $500K to $5 million as the first check. And I can invest in Europe and North America.
Cool.
Broadly speaking, I do kind of vertical software companies that are serving products powered by machine learning, dev tools and infrastructure, as this audience knows really well, is like important for powering machine learning applications. Definitely. And then I also go into other areas like biology, life sciences, defense, and whatever else might kind of unfold in the future.
Very cool. The company was founded on investing in AI first companies. And I guess AI had its takeoff moment end of last year, beginning of 2023. I guess I would imagine when you founded the firm, you had in your mind, like one day this will take off and it will take off in a very specific way. Was the shape and the nature and the fact that it's a generative model, like how did this take off compare to what you had in mind when you founded the firm?
I think progress for me, like in machine learning, is like it's like a steady kind of grind, like any scientific craft. It's kind of improving every year on year, by like single percentage points, et cetera. It's not really like an exponential. And then you have these like capabilities improvements that just happen, and on the moment they might not be super obvious, but in retrospect, it's like a step change. And then you like keep growing, you keep slogging, and then there's a new one that pops up. And these kind of inflection changes, I think, are quite unpredictable. Hence the analogies with how ingrained this field is in science. Kind of discovery oftentimes is quite random. And so I didn't really see, like, even 10 years ago when I was in graduate school, there was a lot of genome sequencing experiments and other experiments trying to throw a lot of data at biology, and we were developing tools to parse that information and make sense of it and make predictions and et cetera. And then, like a lot of these similar techniques were also present in other big data fields at the time, like finance, insurance, ads, and as software sort of like increasingly sweeps over different areas of the economy, like different industries and use cases become ripe for applications of machine learning, because there's like pressure to perform, there's cost pressure, there's infrastructures in place and data and sophistication of the customer, and new product experiences you want to power. So I think the long-term arc is like very clear to me. It's just sort of unclear sometimes until you see it, when different capabilities unlock problems which were previously untractable. And I think we can go into a couple of examples like drug discovery or self-driving cars or defense or other areas like that, which you couldn't really make a big impact in until you had capabilities, and then all of a sudden it's like, whoa, this is solved.
Right.
Um,
But that's the thing, right? Like I think I followed the space as well as an analyst the last
yeah,
couple of years, and I think most of it was kind of assumed that the big markets were probably autonomous driving, maybe robotics, maybe kind of the more classification-based networks. And those things certainly all made progress, and we had companies based on those. But the big moment, like everyone knew that some moment there would be a big moment. The big moment came in the form of these generative networks for text and I guess images as well, which is like we knew the technology was there, but it's still surprising how that was the 0 to 100 million user step function. Like it surprised me. I don't know how it felt from your end.
I think a lot of the kind of use cases that you can see today were tried like over and over and over again. Like in the past, it just like didn't work. Like we've been trying chatbots, we've been trying to do text summarization and generation, trying to do image generation for a while. I mean, recall like generative adversarial networks were like all the rage a couple of years ago, and we thought that would be like the journey to image synthesis, and it turns out it maybe wasn't. So I think consumers are just tough customers, like if you showed them some of the capabilities a couple of years ago, like those were in the moment like pretty outstanding, but they just didn't really like hit the bar. And then now we've kind of created, I think, the first few viral consumer grade use cases for machine learning, where it's no longer, I don't know, optimizing something in like some deep dark data center somewhere or some backend software application that no one can like touch and feel. Now it's like properly consumer grade, and then with that like captures a lot of imagination. And you're right in a way too that like it's also surprising that like the network architecture that won is like quite simple conceptually, at least. I mean, obviously the math is hard, etc. But like we can argue as to like whether these models are like just doing next token prediction or if they're learning, a world model or something more sophisticated. But it is like remarkably elegant that like the world can be modeled as a sequence, and quote unquote all we're doing is predicting sequences.
Yeah, I think maybe the gap that got closed is the user interface to these models. It's interesting that both cases with, I guess, OpenAI's ChatGPT and Midjourney, both companies found a very specific way and a user-friendly way, although I think the Midjourney way is kind of pretty hard to access the magic behind the scenes. And this user interface made it possible to kind of get to the goodness quicker.
And we also created, I think, the substrate for it. Had Instagram not been on everyone's phones, and Facebook and Twitter and all these other kind of Gen 1 products, then I don't think people would really vibe as much as they do with these capabilities. Like I think Midjourney took off a lot with architects, and there's a lot of like architects on Instagram that share like pretty crazy designs because that's kind of like what they do. And so had you not had that substrate and that home already existing, then I think distribution would have been like less viral in a way.
Definitely. If we look at the broad landscape of AI companies right now, we have companies doing foundation models, and then we have companies doing more vertical specialized things, maybe with fine tuning. How do you broadly, I guess, understand and see this industry and expect it to play out? Does it follow the kind of the power law of it, which seems to dominate every generation? Last generation, Facebook and Google dominated, Apple and Google dominated mobile. It seems like there was always this 80% mass at every technology kind of transition. And right now it looks like it's OpenAI and Microsoft and maybe Google again. How do you see that playing out? And do you think there's any chance companies other than OpenAI can have a real shot at foundation models?
So the way I look at it is like these foundation model companies are creating like very advanced capabilities, and then you kind of have to ask yourself the question of, is a model a product in and of itself? And historically I'd have said no, because like if you just give somebody an image classification API, like that's one sliver of a complex value chain. In, for example, like we have a company doing health and safety in industrial and manufacturing environments, trying to protect people from doing dangerous things. You go to those facilities and you just give them an image classification API, they're like, okay, like this is one part of the problem, but like I'd much rather just buy like a full SaaS solution that like speaks to me, integrates with everything, and the rest of it. Then when you go towards like more advanced models that can be used for lots of different use cases because they are like quite general purpose and generative, then perhaps they like become a bit more of a product because they are so general purpose. But I think they still struggle from price discrimination. It's like if you're just going to charge $20 for a user that's like Ken Griffin's analyst or something at Citadel, and then the student writing an essay, like that seems a bit bizarre of a like business strategy. And so basically you're just betting on like massive volume, which maybe could pan out, in which case there's going to be one or two vendors. And then I think a bit jury's out as to whether, aside from the complex monetization corporate structure of OpenAI, whether OpenAI prints more money than Azure does. Mm-hmm. But at the end of the day, like I personally would still bet on like a more vertically integrated like software company that makes use of capabilities versus betting on like the company that generates the capabilities through models. And so yeah, I haven't done too many investments in foundation model companies. I think it's still like very early days. It's tempting to make these predictions as to where things are going. I think at the end of the day, you just want to like try and see the present really clearly, and then try and like make educated decisions as to like where to place your bets. And my bets are more on like vertically integrated companies, like own as much of the risk in delivering your solution to the customer, so like it's as risk-free as possible. And to me, that's not exposing a model. That's like a model, in this case, would be like a model plus prompts plus like buffer guards plus UI plus integrations, et cetera, et cetera.
Right. How do you think of foundation models as where it fits, I guess, in the computing software stack? Because it seems like this is a completely new piece, an extremely large piece that just appeared out of the blue. We've been used to, the whole computing stack has been built on microprocessors, memory, operating system, applications. And no one predicted or thought there would be another piece that is extremely large, that is this powerful. And it seems like, just like the graphical user interface, when it came out, we soon realized this will be a pillar. Do you think if you draw the architectural diagram, is this something as core as Linux or a kernel that is everywhere? It can't really be free if it's served from the cloud, but it seems like there's been a ton of effort and progress in quantizing it and running it locally. Lots of people running even 30B parameters on a computer laptop. How do you see the architecture, I guess, evolving?
Yeah. I think it could be. I don't exactly know where it would fit in the stack, but it does strike me that it's kind of doing a quite high quality analyst level work. Like if you sort of look at all the like traditional machine learning pipelines of like predicting what's in an image or predicting what's in text, like the outputs are then served to a user through a graphical interface or something, and then the user has to then like ingest that information and do some analyst task with it. And now it strikes me that you can basically like replace that with like one of these generative models that consumes the output of traditional machine learning system and then like munges it and does the analyst task, and then turns out a more refined piece of information, just like you kind of go through the commodity refinement kind of approach with like coffee beans and stuff, all the way to like coffee in your coffee shop. The other idea I've been thinking about, two ideas. Like one is I have this like sense that graphical interfaces will change like dramatically and should change dramatically as a result of these capabilities if they do pan out, because in one sense, like a web app is basically compartmentalizing a sort of job to be done in a set of frames with things you click on and things you have to manipulate. So these are sort of like micro tasks that, when combined together, solve an overall objective. And and we've been using traditional machine learning to sort of solve these micro tasks, like classify this, do sentiment on that, clean up this, whatever. And with generative, if the idea is that you can just give the model like the overall objective and the goal you're trying to solve for, and not necessarily instruct it as to how to get there, then it should be able to like accomplish more of these tasks by itself, and therefore no longer have to like expose the same workload to the user through a GUI.
Yep.
So why should you have like 10 frames in a GUI as opposed to 2?
Mm-hmm.
And then if that's true, then like I think it's going to be easier as like a new software vendor to come in with a proposition and a pricing scheme and everything that fits that paradigm than an existing one that tells their customer, hey, like your SaaS product is going to have like 8 times less frames in it, and you have to pay me twice the price. Like, yeah, no thanks. Then the other idea, I mean, this is a bit more nascent, but like it strikes me that the last 10 years or so in terms of software architecture, we've gone from a world of monoliths, like sort of big software blocks where everybody works on the same time. They're kind of a pain to debug. They're slow. Sometimes they're expensive, unwieldy. To microservices, like atomize the hell out of it. And then with machine learning, it seems like we've kind of gone the inverse. Sort of gone from like microservices, basically like small models that do like lots of very specific tasks, to like one ginormous system that does everything. And it's like a bit slow, unwieldy, expensive to maintain. And part of me is like thinking, is that, given that we went the opposite way with like software design, is this the right design pattern for machine learning? So I can kind of see it going 2 ways, if that's like a correct way of looking at it. It's like one way is like you just re-atomize everything, do like distillation or something, or you use like the one ginormous system as like a kind of brain, for lack of a better word, that figures out how to solve a problem, and then selects from a series of microservices that are like specialized models that do X, Y, Z.
Yeah. And I guess maybe even the large models today are sort of doing that implicitly. I think there's some research to suggest that it's kind of like it is trained like one big model, but really it has basically selected optimal submodels inside of itself. Not an explicit mixture of models, but kind of an implicit one.
Yeah.
And I guess what's really impressive to me about large language models is how they solved the robustness of language understanding. Like I could ask ChatGPT a number of ways of the same thing, using street slang, using formal English. It would all understand, and it was never designed to address that. Like I think the understanding of language is kind of like a core capability you have to have, even if you atomize. And then obviously fine tune to whatever tasks that's specialized.
Yeah. So it is also a bit of, it's also just interesting that you have to almost go through like a massive model stage to then ultimately solve like a micro task. Like it seems like an inefficient way of getting somewhere,
Yeah. I think an interesting question might be like, how compact can the representation be in the end? Like humans are, I don't know, you've seen probably the video of like a dolphin being born. The second it's out of the womb, it knows how to swim. It has some great pre-trained weights built in, and it can be very compact. So I think it'd be very interesting the next couple of years to see how, right now people have got it working on a MacBook. How small can we really get this core language robustness capability? Could it fit in a gigabyte? That would be amazing.
Well, it seems like you can fit on an iPhone now as well.
Yeah. You and a co-author a great report, State of AI. I think, when does it come out every year?
In October.
Okay, so it's almost due, but we're more than halfway through the year. You've made some incremental updates and tweeted it out based on some data. How does it look at the mid-year point? What are the most interesting things that you found?
Yeah, so we have the full-blown annual report, and that's very much like a summer project. So I will start putting the kind of sketch document together in the next couple of weeks. It's going to be intimidating for sure. And then sort of a side branch to the report that we started last year is the compute index, with the kind of specific lens on basically like who's winning the chip wars, is the way to put it. Mostly because it was like an interesting contrast to how the model layer seemed to be very like collaborative and open and like lots of options and therefore like sort of decentralized, and then like the compute layer is like massively centralized. I think everybody sort of knew this in the industry, but we didn't really have like numbers to put on to quantify like what the gaps were. So yeah, that specific project is basically like tracking all mentions of specific chipsets in AI research papers that are used in those papers for the experiments. And then we plot like relative usage, relative popularity, basically, of different cards in these papers. And, unsurprisingly, like a lot of the papers make use of NVIDIA hardware. And so you can sort of see like the H100 is like super nascent, is now kind of like popping up a little bit from the bottom, and A100s is popular. And then we also look at alternative like AI semiconductor companies like Cerebras and Graphcore and others, and then track their contributions. And then lastly, we also enumerated the size of public, private, and national HPC clusters, and we use the A100 as sort of like a normalizing variable. And there we see that a lot of nation states like don't have very much capacity, and many private companies are significantly larger than some of the national capabilities. So yeah, I think the whole industry like knew that NVIDIA was the most popular vendor. Like that's no secret, but it still like amazes me as to how that information is not like broadly distributed or broadly known, as is evidenced by in Wall Street's sort of surprise like 2 weeks ago that, oh shit, like NVIDIA's like beat their target.
Yes.
I think everybody in the industry could have told you that. And it's kind of interesting seeing like various like startup pitch decks for compute vendors, because then you see like, oh, startup X like did deal Y with company Z, and it's like huge numbers.
Yeah.
So,
you were an early investor in some of the AI hardware companies. How has this thesis turned out versus your initial expectations? What are the key learnings here when you look at adoption of AI infrastructure, especially alternatives?
I think it distills down to like ease of use and like knowledge of the tooling. And I think that's also like not a surprise to people in the industry. It's like you can kind of design like a car that's 100 times faster than a car that exists today, but if the gearbox is something that's like way too hard to learn, then like no one's going to drive it. Basically like the TLDR. So I think some of that is changing, and it's changing a lot faster than it was before, because it is unfortunately like super hard to, as better than me, to like design a new chip and like fab it and test it and raise the money for it and convince people it's the right way. Plus like competing on the software side. I mean, it's it's an insane like endeavor. And I think I have a lot of like respect for people doing this today compared to people who were doing it 10, 15 years ago, when like the workload that you were designing your chip for didn't really change that much,
right,
in the span that you had to design the card. Whereas now, even through the generations that new vendors have lived through, I mean, we've gone from like Keras to TensorFlow to then PyTorch, and that has implications on your software stack. And if that happens halfway through your tape out, like that's not like the best. But I think now is also like a good time to keep pushing on this, because there are real delays, there are real hardware limitations, and people want alternatives. Like they genuinely do want alternatives. So I think it's incumbent on the challengers to provide them these alternatives. Now's the time to sell COVID tests during COVID.
Yes, now is definitely the time to sell compute infra.
Exactly.
Are you still seeing deals? Like, are companies still being founded for computer infrastructure? I mean, it seems like most of the action was around 2016-ish. Is this still happening?
I have certainly seen some companies, raise money to do new chip designs and with a focus on large models and generative models. Admittedly, they are very specifically just targeting 5 customers.
Like the hyperscalers, basically.
Yeah, the hyperscalers, and then OpenAI and DeepMind and others who are Anthropic, et cetera, who are doing kind of these big experiments. And yeah, I mean, it must be like a stressful job.
Yes, for sure. I applaud their courage. I guess we're seeing it from the front lines, and it's been a couple of years at Cerebras. You mentioned one of the challenges is, of course, the rapid evolution of model architecture, and today we seem to have at least solidified on transformers as this kind of core architecture. It's supplanted a lot of the others. Do you one thing that's great about AirStreet is that you really get into the research side and you talk to people very early stage. How does it look from a neural network kind of architecture side? Does it look like transformers will become kind of like a pseudo standard that we'll be building on for the next 10 years? Or do you see this as yet another phase? Like, because it's very hard to tell. When LSTMs were normal, we thought that was going to be an ongoing thing. And now we have this. Are transformers somehow more permanent than all the stuff that's come before?
I mean, it does seem it. I was looking back at the State of AI report 3 years ago in 2020, and there we had a slide where we said the transformer's ability to generalize is remarkable. It can be thought of as a new layer type that is more powerful than convolutions because it processes sets of inputs and fuses information more globally. And then the example that we took was, I think, a paper that wasn't that popular at the time, which was OpenAI's image GPT, which is basically like a GPT-2 that was trained just on text. It was fed images in the form of a sequence of pixels, and then it was tasked with auto-completing images. So you had sort of like a tennis ball that was like cut halfway, and then you fed it the sequence of pixels in the tennis ball, and then you asked it like generate the rest of it. And just like it could generate, the remainder of a poem or something, it like generated a tennis ball. And I think that was pretty early evidence that like, okay, these systems are far more general purpose than you think. And therefore any kind of data stream that you can represent as a sequence and tokenize it could in theory be modeled and effectively perform better than a non-transformer architecture. That was 3 years ago. And then after that, we saw, I think, transformers like hitting state of the art on images. That was, with the vision transformers back between 2020 and 2021. And then, after that, we saw, transformers go into like biology and AlphaFold and things like this. But it like that, all that stuff was certainly not obvious, I think, from that original like 2017 paper, which just said like, oh, it works well on like English to French, and we think it might work well on other languages too. It was like very cute in retrospect.
So nothing clearly on the horizon that might be a new architecture that makes a dent, kind of like transformers, or even like a less influential network. I mean, there's a couple of variations out there, like graph neural networks, and there are people tweaking with adding memory to transformers. It seems, at least to me, it seems like transformers is like a foundation to build off, if nothing else, and we can
yeah. I mean, it certainly seems like quite general purpose. I don't know immediately what might come after that. I think Jan LeCun's team had a sort of spin on this, a newer spin on this recently, but I think it's probably a bit too early to tell. So I think at the end of the day, like, this is like a tool as part of a toolkit, and it just like depends what problem you're solving. If you can still print money by doing object detection with bounding boxes, I mean, you should go do that. It's perfectly fine. You might not need transformers for that. But it's more like going into domains which weren't tractable before, and now they are. And then, as you mentioned, like certain domains, I think have data that just fits really nicely with another architecture, and perhaps like chemistry is one that's really well suited to graphs because like intuitively that's like how humans represent them as atoms and bonds. And so I think like state of the art is still probably graph neural networks to predict, given the structure, like does this thing bind? Is it toxic? Does it dissolve?
Right.
These kinds of properties.
Okay. You do quite a bit of work in kind of the life sciences and drug discovery.
Yeah.
I remember there was a crop of companies also around maybe the 2015, 16 era, Atomwise and Recursion, companies like that. They were maybe the first wave of deep learning drug discovery companies. I haven't quite followed it since. How has their progress been from versus kind of initial promise versus what they delivered? And are we seeing a second generation or maybe third generation of drug discovery companies maybe leveraging modern large scale techniques?
Yeah, I think so. I think the most stringent criteria to judge progress is ultimately like approved drugs, and we don't yet have one that you can point to that's a machine learned drug that's been approved. However, 3 years ago there were no drugs that were in clinical trials that were the result of a machine learning based process, and now we have over 20 of them, and companies like Recursion and Relay and Exscientia have quite a few of them, and the pace at which they're pumping them out is far faster than traditional pharma, far more efficient. For example, Exscientia is an Oxford-based drug discovery company that was founded, maybe even 10 years ago, actually, by some pharma executives and people who worked in machine learning. They had some of their early papers on evolutionary networks for designing drugs. And we became a shareholder in the company through an acquisition of a portfolio company in Fund One. And it's been really like exciting to follow their progress. And they were quite early in the whole like generative modeling space, but now they have almost half a dozen drugs in clinical trials. And if you look at their F1 statement when they went public, a year or two ago, this graph I think that told a really nice story, which was the average number of molecules that a pharmaceutical company needs to synthesize, make in the lab, and test is on the order of several thousand in order to find one that they really like, that they then advance, into trials. And for Exscientia, they showed you a sample of like a dozen different campaigns that are basically a target and a disease indication. And on average, they would have to synthesize 10 times fewer drugs before they found one that they liked. And that also meant that the time it took from start of the project to like, I have a drug I like, is significantly shorter, like on the order of like 6 to 12 months as opposed to several years. So although it's still very early in the overall development of this field, I think it's not going to be too like distant in the future where we'll see a lot of the molecules that are going into clinical trials are actually generated by a machine.
Okay. What stage are they at right now in the clinical trials?
So I believe they certainly have phase 1 trials. They might even have a phase 2. So it'll still take a couple of years. But the other thing that's interesting is a bit like SaaS companies where V1 of their product is like good, V2 is better, V3 is way better. And we know that in the software world, and like customers are used to that. And so we kind of expect the future to be better than the past. I think in drug discovery, we oftentimes, I think, judge like the first molecule too harshly almost and say like, okay, this one sucks and the rest of them suck. But like a lot of these drug discovery companies will mirror progress much more like software companies where, the third and fourth and fifth asset that they develop is going to be so much better, like really beautifully synthesized molecules that are super potent because we've accumulated all the learnings from the ones in the past. So I think the future is only going to get better. And there's so many different like kind of points in the value chain where we can, make a real dent using machine learning that we can get into.
I see. Well, in software, if you build a better version too, you can just ship it the next week. In drug discovery, do you have to go through the whole clinical trial process all over again?
Well, usually these campaigns like take quite a long time. So if you get a new a version of a model that's like good for, a step down the value chain and your molecule hasn't gotten there yet, then it can be useful. But yeah, you can't really do like iterative changes once you've filed, as far as I understand. So, but then like to your topic of like, are there Gen 2 or Gen 3 companies in the space? I think yes. So, whereas protein engineering is like this idea of taking antibodies, for example, which are one class of drug-like molecule, and then introducing changes randomly into their amino acid sequence in order to generate a new sequence, and then seeing does it work better, does it not work better. That kind of form of protein engineering is sort of trial and error. That's kind of broadly been like the history for a long time. But then since the advent of transformers and language models, these same techniques have moved into protein engineering. So invested in a team called Profluent, which is in San Francisco, and the founder of that company, Ali Madani, was on the team at Salesforce that was doing large language models for code. They had a model called CodeGen. It's a bit like Codex, basically. And then he embarked on this kind of moonshot to say, like, could CodeGen do ProGen? Could you do it on proteins? And it turns out you can. They had a paper in Nature Biotech that was published earlier this year where they showed a language model designed for code with a bunch of tweaks could actually, in an unsupervised fashion, like learn the language of proteins, protein function. And then you could get the model to generate an amino acid sequence that gives rise to a protein with specific functionality that's present in nature, but where the sequence that encodes it is vastly different to the natural one. So it's sort of like telling you that large scale and supervised pre-training on tons and tons of protein sequences can then let you kind of navigate into a part of the search space that we as humans haven't discovered through our like artisanal techniques and like random mutagenesis, random mutations that we've introduced. So I think that's like super, super exciting, and kind of unlocks an approach in drug discovery is much more kind of programmatic, much more like directed, saying like, I want these capabilities and my system will generate it.
Right.
Like sort of similar to what we were discussing earlier with the web apps. It's like, I want this. I don't care how you get there. Just like, give me the end goal.
Yeah. That's very exciting. What so these use just standard transformer architectures? It just ports over very nicely for protein generation.
I mean, it generally ports over. I mean, the benefit also of working in biology is you have a lot of priors, like just knowledge of how the system works, and what things are like illegal, functionally like don't make any sense. And so,
yeah,
encoding some of those priors that we've learned through history of biology is definitely useful. So you don't have to like learn all this stuff like tabula rasa.
I see.
But yeah, broadly the concepts transfer really well.
And how large are the data sets native to biology or drug discovery? I mean, for like LLMs, we're at trillion token scale. I guess these proteins get tokenized, like it goes through the same pipeline.
They do.
Right? What scale of data sets? Like millions, hundreds of millions?
No, you can get to the same scales as language.
Oh wow.
With proteins. Yeah. If you go across different species, you go like humans and microbes and animals and things like this. And there's a lot of like conservation across sequences, and broadly like function is traditionally conserved.
I see. So in terms of, I guess, compute load, drug discovery can be on the same order of magnitude as kind of foundational language training.
Well, we haven't really pushed it yet. I mean, the protein work that Ali worked on at Salesforce, I think the model that they pushed was 6 billion. That was the biggest one.
I see.
So still pretty small by language comparisons. So we don't yet know what the scaling laws are, but it didn't look like as obvious as like, okay, just shove more compute and more parameters and we'll sort of get better performance. So kind of makes that feel a bit fun as well, because might not be as like linear progress.
Yeah. Well, previously just betting on more wasn't a popular bet, but now it seems like that's the default option.
Sure.
You have a lot of thought because you work both in Europe and the U.S. on kind of the industrial policy and the regulatory approaches of these different, I guess, geographies and systems. And I've watched with interest kind of the European startup ecosystem. Arguably produced the first deep serious AI company with DeepMind, but it hasn't matured in any, I guess, commercially like a successful outcome, kind of like Spotify, for example. How would you characterize kind of state of the European startup or tech ecosystem today versus 10 years ago? Maybe, I think maybe 10 years ago, it was still, it didn't quite have the norms that were kind of widely applied in the US. Has it, I guess, adopted those things? Are European startups more ambitious than before? I guess, what's the landscape like, especially for like AI startups?
I think it's changed. It's certainly changed remarkably. 2010 or so, plus or minus 2-3 years is like the founding date of DeepMind, and then same thing with which we all know, and then SwiftKey, which was one of the first like swipey predictive keyboards, and that was probably one of the biggest like early exits in the UK tech scene in AI. And I think their first pre-money was like $2 million or something, and then they sold for 250 million, which at the time was like, wow, massive. Which I think it still is like pretty solid. And then since then we've had like a couple of other ones like Magic Pony, which was a lot of money for a small team doing computer vision work. Not strictly speaking like machine learning, but the whole like soft ARM and NVIDIA deal was pretty enormous. And then you've had like quite a slew, I think, of more data-centric companies that are quite exciting, like in the UK and more broadly. I think like the leaders in RPA, robotic process automation, are European, like whether that's UiPath, Republic, or Celonis doing process mining, which is in Germany. Also in like data infrastructure, Calibra, which is in Belgium, and then we've had like a ton in fintech, and I think that's partially because like the UK did a good job on creating regulatory sandboxes for new companies to experiment, and pioneered like open banking, where people could give access to their bank accounts through an API. Mobile payments is like super popular, and like single day transfers and debit cards and like contactless payments are all things we've had for God knows how long. And so we have Revolut, Monzo, and Thought Machine on the infrastructure side, and also in kind of new areas. Like one of the probably leading like crypto companies is So Rare, and it's like a Parisian company. Sure. So I think the ecosystem's like performed really well from where it was in 2010. It's become much more sophisticated. Still can like improve. Overall, like the end value of like large companies is undoubtedly smaller than in the US. And the playbook, I think, for many probably non-consumer companies, particularly in like enterprise software, SME software, data infrastructure, is to start in Europe and then scale your operations in North America, where you have like a more willing and sophisticated buyer universe of companies. On the consumer side, I think sometimes you can grow quite large in your domestic markets. And I think nowadays capital is like pretty global. We have more and more international firms that are represented in Europe that take it seriously, and talent's like pretty mobile. You've had second or third generations of entrepreneurs who for whatever reason like want to come back from the US and start building in Europe. So I think that's exciting. And then sometimes reg plays in your favor or reg plays against you. And my understanding is like reg is playing in the UK and Europe's favor in crypto versus the US. And then we'll see what side of the coin we land with putative AI regulation. That might be the opposite, but yeah, generally like pretty solid upward momentum.
How is the AI regulation shaping up in both the UK and Europe? Are you happy with the direction it's taking or not?
I think it's I think it's moved like pretty fast, and I feel my kind of fear is it's a little bit like reactive, because the pace at which we've gone from like AI is powerful, AI is useful. Oh, and then 2019, 20 in our State of AI report, the main thing that people were getting really concerned about was like algorithmic bias and facial recognition, and we documented a lot of kind of like legislative action in that space, which is like definitely warranted. And we sort of like forgot about that for a bit, and then 2 years ago or something, we highlighted in the report again that there was perhaps not enough people working on alignment and safety, and just ignore the word safety because I think that invokes certain viewpoints, but just robustness and like a system that works well, that doesn't break.
Right.
Like why would we not want that? But there's just generally not that many people working on it. At the time, I think we enumerated 100 people or less in some of the major AI labs working on this, and like nobody attending the safety conference basically, and everybody wanted to go to CBPR and NeurIPS, and then the last like six months, we've gone from that basically zero interest in safety to like we're gonna die.
We're all gonna
we're all gonna die. And I mean that is like a big change in perception, and the challenge is like we don't necessarily know the incentives of all the actors, and the issue is you have sort of like the tech elite, the big tech elite that are having their own incentives. Who knows if it's regulatory capture? Who knows if it's trying to be on the right side of regulation, that are talking a lot to policymakers, and on the other side you have this vocal minority or potentially growing minority of people who believe we're going to die or potentially going to die, and so politicians are like having to react, right? Because like big name people are signing these things, and it's very hard to know what their true intentions are, but like they've declared it, and as a policymaker you kind of have to respond at that point. And there's not that many like pragmatic views that get voiced because I don't know, they're just not attracted to the debate or something. So yeah, just kind of like a roundabout way of saying that I hope we don't like act in haste too quickly. For example, in the EU proposed legislation, which is kind of moving forward, they draw the difference between a general purpose system and a foundation model. And I'm not really sure what the difference is. I'm not really sure people even have a definition of what a foundation model is anyway.
Yep.
I mean, as far as I understand, it was like originally a marketing term. So, just being careful, because the view at the moment is like there is a line of capabilities above which it is dangerous and below which it is not, and I just don't know what that line is and how you can dynamically move it around, as big models can be distilled to smaller ones and still have certain harms. So yeah, I feel like taking a pragmatic view of like there are a certain number of short-term harms like misinformation and manipulation of opinions and things like that I think are like quite pressing compared to this might kill us. And I think it's important to like figure out exactly how it might cause existential risk. And it just strikes me as odd that the like burden of proof is higher on people who say it's not going to kill us than if you say it will.
Yes. It seems
it's basically religion.
It is, and it's kind of like a meme, and it's taken off a life of its own. And we have a cult leader that's very effective in propagating this meme. When we came up with electricity, producing electricity became a national mandate. Now we have this super capability called AI, and now that is a national mandate for many places, from China to the UK to the US. What are you seeing there? What do you think should be done? And should there be a global body that maybe oversees some of that as part of safety?
These are all questions that are definitely worth getting answers to. I'm not exactly sure what they might be at this point. I think it's exciting to see the UK is like taking a forward foot on this. They appointed my co-author Ian Hogarth to be head of the foundation model task force, which is modeled after the UK's vaccine task force during COVID, which like very quickly tried to figure out what the dangers were, how we might solve them, and work for like a quick public policy strategy in the face of the pandemic. And here, I think it'll be interesting to sort of see what comes out of it. I think it is attractive to think that there might be some international cooperation, but at the same time, because there is so much at stake, like financially and competitively here, I somewhat feel like that's maybe not as realistic. Like it will be somewhat game theoretical. Certain countries like India are so far being like quite permissive with AI, seeing it as like an opportunity to really supercharge growth, and
Right.
and other countries are being more timid with enabling its progress.
What do you take
So
for the fact that even the market leader, OpenAI in this case, is basically communicated their desire to at some point to have oversight and to maybe even have, like, it's kind of like preempting a START treaty before even any weapons were built. They're like saying eventually we're gonna need this. Do you see this just as kind of like, is that a genuine expression, or something kind of just for PR or other reasons?
I mean, it's very hard to opine on that, I think, because I don't know. I've never met Sam, so I don't know how he behaves and what his strategies are. I mean, you can kind of read into like this would be like the fiduciary responsible thing to do as a leader of a company, to ensure that like you're part of the debate and part of the narrative when you're creating something new, to set standards, and ultimately it does benefit the organization that helps set them. Just, this is like textbook business strategy. But I do also believe that you can be genuine about this, but I don't think those two things can live like mutually independently. Like they could be occurring at the same time.
Yeah.
But yeah, but I think this is the whole challenge. Is like you just don't know people's incentives, and I think until you know the incentives, you can't really like properly read into actions.
Okay, fair game. Second last question. What is a piece of advice, as specific as you can, that you would give to Cerebras? And if it's easier, imagine that you'd be giving it to GraphCore at the same time, since you're an early investor in GraphCore.
Yeah. I mean, I would love to have like N,000 IPU, GPU, Cerebras cluster that I can go give to startups. that would be cool. No, but I think just ease of use is probably the name of the game here. And I think like like many companies that provide services to startups and help them grow and remove friction and then grow with them, I think there's a cool opportunity to like help these companies that are born like AI first, that want to do like large scale machine learning, that they're born on your infrastructure and grow with you. Those would be the two things.
Makes sense. We completely agree. Last question, ultimate kind of big picture question. It seems like we're on some rapid progress here, and there are just two broad outcomes possible. One is we're kind of going to have AI take off, and that would imply we'll have AGI and maybe superintelligence very quickly after, which would imply the world will look extremely different after that fact, as different as the 21st century looks to the Middle Ages. The other would be we plateau progress, maybe hit another AI, not winter, but like we have a limiter to the amount of progress we have, in which case kind of the world would not really improve too much year on year, which seems like a very odd future to have as well. Both seem very odd and hard to imagine because we've lived through the 20th and 21st century, and it's just been like nice, steady progress. Which of these do you prescribe? And I guess what do you expect to happen in the future as a result of, if our thesis on investing or building AI comes true?
So I certainly think that we have a path from here to maybe like one or two generations, however you define one, of GPT style models like panning out and having like much improved capabilities. But like what that exactly looks like, and then what happens beyond that, I think, is quite uncertain. Like whether it's, we run out of like human generated training data, and now like machines are kind of generating training data or generating feedback that we're using to train the system. And like, I don't know how this like recursive cycle will pan out. And then I think we'll just hit like some really fundamental like physical constraints of either like running these things or training these things or the cost of them. This is probably like a coarse analogy, but I remember, many years ago when Netflix ran that recommendation prize, and like there was a model that was really good, but it was just too expensive to serve, and so they just didn't use it.
Yeah.
And so like another kind of thing another case study you could kind of generate is like how large a model would you need to get to until inferencing it would be more expensive than minimum wage. And maybe there's a point at which like it's too expensive and it's better to use a human. And so then we'll have like a shortened tail of the tasks which will be solved by computers and other ones that will be still solved by humans. I don't know if like, I don't know, I'm just like inherently skeptical, like as a scientist, I guess. So like, as opposed to like a techno-utopist. So my default would be like, I'm not sure like transformers are all you need for general intelligence, but again, like we don't have like a super good definition of that. If you were to use just one that says like, a model can do any like economically valuable task in a digital environment on a computer better than like the average human, then I think we're not that far from that. I mean, you could even argue that like ChatGPT is better than the average human in most things, because we don't have like an API to all the knowledge in the world that can be accessed and crunched in seconds, like that thing can.
If that comes to pass, and it seems like it's not too far out, doesn't that imply a very, very dramatically different future? Like productivity levels, norms of how anything gets done. Like, do you fundamentally feel the world is about to get weird soon?
Maybe I'm like in a weird spectrum, but I don't think so. Like I think human inertia is like such a big thing. Like human behavior doesn't change very fast. Humans are rate limiters for like everything. Humans decide like if they use things or don't use things. I mean, like the number of like software products that should exist and like industries that should transform with software but don't because humans just don't want it to is vast. Like why does like government bureaucracy suck?
Yeah.
Why does your airline suck? Like, why does like a call center suck? I mean, so many things suck, and like they would be a lot better if there would be software. Now, if there's AGI, does it like automatically not suck anymore? I'm not sure.
Yeah, someone still has to decide to implement it.
Yeah, and human inertia is like something that's like a significant force to be reckoned with.
Yes, for sure. Nathan, it's been a great chat. Where can people find your work?
Yeah, Twitter, like Nathan Benaich, or generally probably like the monthly newsletter, just Nathan Benaich on Substack.com. It's called Guide to AI.
Awesome. Those are great resources, and we look very much forward to your 2023 State of AI report, and hopefully Cerebras will be featured prominently.
Yeah, with pleasure.
Awesome. Okay, Nathan, very nice talking to you. Speak next time.
Thanks.
Okay.